Hi everyone. Ya, nak test sekejap. Lagi. Waalaikumsalam. Hai. Dia sebab dia ada 2 monitor kan, so ni kena tengok, yang ni pun kena tengok. Tu yang saya pusing tengok. Waalaikumsalam. Sekejap, saya rasa kita tunggu sampai dalam 4-5 minit ke macam tu. Lepas tu kita boleh start lah. So sekarang siapa yang dah masuk, so sekarang boleh buka Google Form dan boleh daftar kehadiran siap-siap lah. Jangan lupa semua orang daftar kehadiran siap-siap. Jangan lupa daftar kehadiran. Okay, so kalau perasan dekat channel YouTube ni, dekat tepi ni dia ada live chat tau. So kalau ada apa-apa soalan, so nanti boleh tulis dekat situ lah. So nanti bila masa saya free sikit, saya akan tengok dekat situ dan kita akan tengok lah kalau ada apa-apa soalan yang saya boleh jawab. Okay, 2 minit lagi. Lepas tu kita start. Masih sama. SN015. Kod masih sama SM015 Okay, so dah 4-5 minit. So mari kita mulakan. Okay, so untuk lupa change the language, right? Okay, so for today we are going to start with the number system. So basically we're going to do the real number and then a little bit of complex number. Okay, so those are what you need to know in real number. So you should be able to define the natural number, whole numbers, integers, and then prime numbers, rational numbers, irrational numbers, and then you should be able to represent the rational and irrational numbers in decimal form. Represent the relationship of number set in a real number system, diagram D, showing that n is a natural number. So natural number is a subset of the whole number, and the whole number is a subset of an integer, and an integer is actually a subset of the rational number. And then we need to show using the Venn diagram that when we do the rational number union with irrational number, we are supposed to get a real number. Okay, so now D, you should be able to represent the open, close, and half open interval and their representation on the number line, and then find the union and intersection of two or more interval with the aid of number line. So normally if you want to do the union or intersection, you must use number line. Okay, so let us proceed with the next one. Okay, so real number, those are all real numbers. So let me proceed straight away with the definition. So natural number, so this is actually the counting number. So this is n equal to 1, 2, 3. So if you add 0 to this natural number, that is actually called the whole number. So these are the natural number plus with 0. And then prime number, so prime are natural numbers that are definitely to be more than 0 and can only be divided by itself and 1. So prime numbers. Integers, okay, so integers, so you can have whole numbers. So whole numbers is this one, 0, 1, 2, 3, and so on, or the negative of counting number. So counting number is this one before this, 1, 2, 3, 4, and so on. So these are counting numbers. So the negative of counting numbers is this one, -1, -2, -3, and so on. Sebab ni baca je tau, so laju sikit Okay, so those are known as the negative integers, and then we have positive integers as well. So the difference is for this one, z plus, z minus. So z minus, negative, z plus, that one will be for positive. Okay, so done with integers. So now let us refer to the rational number. So rational number, it is a ratio or a quotient of two integers. So this is the basic definition. We can easily write them down as A over B, where both A and B must be integers. So this Z over here is an integer, but B cannot be equal to 0, because if we have 0 in our denominator, then everything else will become undefined. So that is why we do have one definition over here, where B cannot be equal to 0. So both A and B should be integer before we can say that it is a rational numbers. Okay, so if we are referring to some decimal places, then it should either be terminating or repeating. Okay, so for example, 3 over 2, so this is in quotient. So in quotient, 3 over 2. So both of them are actually integers. Or if you represent them using decimal, then you have something that is stopping. which is 1.5. So we stop after 5. So this is stopping decimal or terminating decimal. This is -1/3. So integer, so both of them are integers. And then if you represent them in decimal form, this is -0.3333 dot dot dot. So we have something called the repeating. So this is the case where it repeats. So sometimes we don't want to write them down as this. So sometimes we do write them down as 0.3 with a bar. Or you can use a dot for it as well. So 0.3 with a dot. So the same meaning actually, both of them simply means that we're going to repeat the same number infinitely. Okay, so that is for rational number. Of course, we have irrational number as well. Oh, by the way, this one, 4/7, as you can see, 0.571428. So 571428. 571428, 571428. So we keep on repeating the same number. So again, this one must be a rational number. So we can easily see them from fraction, but sometimes you don't have a fraction. So sometimes you do have something with decimal, so you can easily see them using decimal as well. Okay, so irrational number cannot be expressed as a quotient or ratio of two integers. So before this, we can easily write them down as a/b, where both of them are actually integers. But this time, if you have a/b, one of them is definitely not an integer. Okay, so if we are referring to some decimal places, it is non-terminating and non-repeating. So we are not going to repeat the same digit, and we are not going to terminate them after a few decimal places. So that is why we call them irrational numbers. So for example, for this one is square root of 2 or set of 2. As you can see, this number, we don't have any repeating number, and it is not terminating because we have the plus dot dot dot. Same thing with a pi. So pi is 3.14159265 and so on. So this is non-repeating. So we didn't repeat the same number. And then this is non-terminating as well because we have the dot dot dot. So another one, you might see this previously in your school, E. Oops. Why they didn't let me write down E? Oh, E. Tak nak bagi. Tak apalah. Cing. Okay, can. Okay, so E is actually Euler number. So Euler number, or sometimes some people might call it exponent. So I do call it exponent sometimes, but it is actually an Euler number. So you can use your calculator. If I'm not mistaken, it is 2.71828 dot 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 something. So this is also an irrational number. Okay, so there are two things: rational, irrational. Okay, so now relationship of number set in real number system. Okay, so before this, we have learned about natural, whole, integers, and rational. So this is how, if we want to draw them in a diagram, so we start with the smallest set. So this is natural. If we add 0, it will become a much more bigger set, which is the whole number. And then if you add with the negative of the natural, it will be a much more bigger set called the integer. And if you add with some of the fraction, you can get a much more larger set, which is irrational numbers. And as you can see, rational and irrational, they don't mix. So jangan campur-campur, they don't mix. And if you combine all the rational and irrational number, you can get a much more larger number set, which is the real numbers. And in fact, real numbers is actually not the largest because we can have something else called the complex numbers. So itu yang paling baru lah, the latest one. Okay, so we're done with this. Okay, so from here, you can easily see that the natural number is actually inside the whole number. So that's the reason why we say that n is a subset of the whole number. And then the whole number is actually inside the integer. So n is a subset of w, sorry. So w is a subset of the integer, and then integer is actually inside the rational, so integer is a subset of the rational. And then as you can see, the rational and irrational, if we combine them together, so unions stand for combine, so you unite them all together, so rational and irrational, unite them, we're gonna get a real numbers. Okay, so now for example, we have a number set S. So we have -9, square root of 7, 1 over 3, pi square, 0, 0.13 with a bar, 4, 5.1212, dot, dot, dot. Identify the set of, so we got natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Okay, so basically I'll give you around 2 minutes, I think. 2 minutes for you to determine which are the real numbers, which are the natural numbers, and so on. So masih tak cukup je 2 minutes. I think 3 minutes lah. Better for me to give you 3 minutes. So I'll give you 3 minutes for you to check your answer. Not to check, to do. Okay, so 3 minutes starting from now. Nanti next time saya pasang muzik lah Bosan lah pula tak ada muzik. Okay, bye. Okay, so done. So now let us check our answer together. So semua orang dah siap ke? Cuba tulis komen kat situ. Siap dah? Ke nak masa lagi? So tulis. Oh dah siap dah. Ramai dah siap. So jom kita check. Let us check. Okay, so now natural number. Balik kan. Okay, natural number. Okay, so natural number is definitely something positive. So definitely not this one. There's only one natural number over here, which is 4. So only one of them, 4. B is the whole numbers. So whole numbers is actually natural number plus with 0. So I do have 0 over here. So 0 and 4. So those are the whole numbers. And then C, integers. So done with the positive part. I do have negative 9. So negative 9 is one of the integers. So negative 9, 0 and 4. So now D is rational numbers. So rational numbers, if you want to write them down as a fraction, it should be integer over integer or decimal, terminating or repeating. Okay, so this one is definitely a rational number. This one no, this one yes, this one yes, this one, this is repeating, so yes, yes. This is also repeating, so yes. Okay, so that is our rational number, negative 9, 1 over 3, 0, 0.13, 4, 5.1212, dot, dot, dot. And then irrational number, whatever that is not a rational number, which is square root of 7 or set 7 and then pi square. So the real number, is actually everything. So those are the real numbers. Okay, so now how many of you get everything correct? I want to check berapa orang yang dapat betul semua. Semua orang betul ke? Tak, ada yang salah. Biasalah tu. Kadang-kadang sebab tak nampak nombor 4 kan. Slowly. Lama-lama dia okey lah. 4/6. Boleh lah. Kebanyakannya 4/6 kot. Sebab yang ni mungkin ada yang termiss sikit. Betul 2 je. Tak apa. Nanti kita contact. Kenapa betul 2 je. C, E, F. C, E, B. Okey, tak apa. Nanti kalau kata tutor saya, nanti kita akan discuss balik Kalau kata ada mana-mana yang 4/6, Allah kesian tak dapat betul semua. Tak apa, slowly. Banyak kan, nama dia pun banyak, terms yang banyak. Lagipun macam tiba-tiba je kan Miss sebut banyak-banyak nama set tu kan, pening juga kepala kan. Tak apa, slowly. Saya nak proceed yang berikutnya. So untuk tutor saya, kalau rasa macam masih ada yang tak faham untuk yang example ni, so nanti saya minta supaya contact saya lah. So nak hantar telegram pun boleh, ataupun kalau rasa macam masih nak tanya apa-apa pasal ni, sekejap lagi awak WhatsApp saya pun boleh juga dekat dalam group WhatsApp kita. Kan kita ada group WhatsApp. Okay, so now the next one. Okay, so interval of numbers, so all the numbers between the two endpoint, excluding or including endpoint. So we have two types, either you include the endpoint or you doesn't include the endpoint. So later on, I'll teach you better about this. Okay, so this is called infinity. So this symbol is to indicate boundless. So normally we refer to either positive infinity or negative infinity. So positive infinity is something on the right most, and negative infinity is something to the left most. But we didn't know what number that is. That is actually just a symbol. Okay, so 3 methods to show interval. So this one, we're going to use them more in chapter 2. Okay, so we have inequalities, interval notation, as well as the number line. Okay, so if you want to include any number, normally we're going to write them down with an equal sign. So you do have the equal sign over here. And then if you want to have some bracket, then this one should be a square bracket. If you want to draw a number line, this one should be a solid circle or a dense circle, either one. Okay, so to exclude, that means not including that number. So we don't want to include that number. So when you want to write down them in inequalities, you shouldn't write them down with an equal sign. So tak sepatutnya ada equal lah. So greater than, less than. If you have a bracket, it should be a simple bracket, or normally we call it a round bracket. And then if you want to draw some number line, it should be an empty circle, only empty circle. Okay, so for example, this one, we include 1 but we exclude the 5. So this one is in inequality, so x greater than or equal to 1 but x must be less than 5. So in interval notation, there are some equal sign at 1. So this one, you must put some equal sign. So a square bracket at 1. At 5, there are no equal sign. So that means a round bracket at 5. So if you draw a number line for them, so 1 definitely need to be on the left hand side. Everything must be in order. So the leftmost must be the smaller number. The rightmost must be the bigger number. Okay, so at 1, we have an equal sign, a square bracket. So this is definitely a solid circle or a dense circle. At 5, without the equal sign, so a round bracket. So that means this one should be an empty circle. So that is how we want to write them down. Okay, now next. So intersection and union. So intersection and union operation can be performed on interval. So we can do union or we can do intersection. So sometimes we replace the word union with or. Sometimes we replace the word intersection with and. So this U is or, this N or inverted U is N. So U or N. Boleh lah. Okay, next. This is for joining two set and intersection is for overlapping two set. So this one, you want to combine two lines together. Intersection, when you want to overlap two lines, you want to find where does it overlap. Okay, so solve the following using the number line. So the first one, we have 0, 5, union with 4, 7. So keep in mind, this is a square, so that means you should draw a dense circle at 0, an empty circle at 5, empty circle at 4, empty circle at 7. Okay, so now let us see what happened when we do A. Okay, so start with the smallest number on the left hand side. So 0, 4, 5, 7. So the first line is 0 up until 5. So this is 0 up until 5. As you can see, at 0, this is a dense circle. At 5, this is an empty circle. And then we have another number line, 4 until 7. So the second number line, 4 until 7. So now union, what does union mean is that we need to combine those two lines. So combine them together. What do you have? Is actually starting from 0 up until 7. So 0 up until 7. So the sign over here is a closed circle or a dense circle. So this is a square bracket at 0. At 7, this is an empty circle. So what you call it? Simple. Bukan simple. Apa panggil tadi? Normal bracket pun boleh lah. Normal bracket. A square bracket and one normal bracket. Okay, next. Okay, so we have negative infinity until 5, union with negative infinity until 5, overlap with negative 1 up until 9. So firstly, draw a number line first. So who on the left hand side and who's on the right hand side? So we have -1 on the left and then 5 and 9. So -1, 5, 9. So now -5 up until infinity. So negative infinity is somewhere on the left hand side up until 5. And this one should be an open circle. Okay, so this is negative infinity up until 5. And then you have -1 up until 9. Okay, so be careful at -1. This is a dense circle because this is a square bracket. This is a simple bracket. So this one should be an empty circle. So now you want to overlap them together. So cari tempat yang dia bertindih lah. So overlap them together. I do get this region. So that is -1 up until 5. So -1, don't forget this is a square bracket because you have a closed or a dense circle over there. And then this one is an empty circle. So that is the reason why you have a simple bracket. Excuse me, sorry. Okay, so now let us proceed to another example. Example 3. Okay, so given that A is X such that, so this is normally, we call them the set notation. So if you want to write down something in the set notation, we have to write them down using this X such that. So this double dot simply means such that. Okay, so X such that X is in between -2 and 4 including -2. So this is the set notation. And B is X such that X is in between -5 and -1 including -1, or X is in between 2 and 6. So now we have to find what is A union B and A overlap with B. So we have to set A and B. So make sure A is on one line, B is on another line. Pastikan ada 2 layer, 2 level. Okay, so now draw the A and the B. Okay, so this is what I mean by 2 layer. So you have A first set or the first interval, so that is the first layer. For the second interval, interval B, we have 2 sets, so that is why for the second layer you have 2 line over there. Sebab dia ada 2 set Okay, so now we want to combine everything together because this is union. Combining them together. Kau nak try lah? Tak apalah. Saya bagi je lah jawapan Sekali kan kita tak masuk complex number. So I'll give you the answer for this one. But later on you can try A union with B. So combine them together. So what do you have is starting from -5 up until 6. So add -5, an empty circle, add 6, an empty circle as well. Okay, so those are union. Another one is the overlap. So we have to find the intersection for them as well. Okay, so now A overlap with B. So overlap them. So this is the first region. That is the second region. So the first one is -2 up until -1. The second one is 2 up until 4. So we have 2 value over there. -2 up until -1, 2 up until 4. So since we do have 2 separate interval, what do we need to do to combine them together is we have to write down union. It simply means that our answer are either in this interval or this interval. So that is the reason why we have to write down the U or the union. That means you have to answer. Boleh letak sini boleh, sini pun boleh. Either dia macam kalau kata kita solve soalan biasa, either X equal to 1 or X equal to 3. Lebih kurang macam ni lah kiranya. Okay, so with that, Let us continue with the complex number. Okay, so in complex number, we have to represent a complex number in Cartesian form, define the equality of two complex numbers, and then we have to show the conjugate of complex numbers. So there are three learning outcomes for complex numbers. Okay, so certain equation doesn't have any real roots. So for example, x squared plus 1 equal to 0. If you want to solve them, you're going to end up with x squared equal to -1. And then if you want to have x as your subject, then it means that this one we must put a square root for them. But square root of a negative number doesn't have any solution in the real set. So plus minus -1. So what we can do is that we can take I equal to the square root of -1. Then the solution is either x equal to I or x equal to -I. Therefore, we do have some solution, although that is a complex number. Biasanya yang ni kita pakai untuk elektrik sikit lah. I kan kalau tengok elektrik I kan. Okay, so complex number x equal to I or x equal to -I. Okay, so the imaginary unit I helps to solve equation with no real root. So if we don't have any real root, then we can use I to find some of the roots for them. Sebab bila kita jawab soalan, mesti kena ada jawapan. So apa jawapan dia? Contohnya macam ni lah. I, imaginary number. Bahasa Melayu apa tak tahu. Okay, so imaginary unit I. We can actually express the square root of any negative number as a real multiple of I. Okay, so for example, the square root of -16. So you can easily separate this into square root of -1 times with 16. And then square root of -1, square root of 16, square root of -1. So we learned about this before, where we define this as I. And then square root of 16 is actually 4. So you can easily write them down as something in terms of I. So one thing that you should take note is that the power of I can be simplified. So that means if you do end up with I cubed, I to the power of 4 or I square, that means you should be able to simplify them. So the highest power of this imaginary unit should only be I to the power of 1. Other than that, you can easily simplify them. So for example, I cube is I square times I. So I square, forgot. I square over here. So I square is equal to -1. So you can take this value over here. So this one, you must remember them, memorize them. I square is equal to -1. Or I is equal to square root of -1. So memorize either one of them. Okay, so I cube is I square times with I. So I square is -1 times with I, therefore you're going to get -I. So same thing happened with the I to the power of 4. So that is why you can easily change it to become 1. So now the highest power of imaginary unit is always I to the power of 1. Okay, so now next. Okay, so the complex number z equal to x plus yi. Normally, this is how we write down a complex number. So z is equal to x plus yi. So it must consist of two parts, the real parts and the imaginary part. So this one is called the real part. This one is called the imaginary part. So real part is something without the I. Imaginary part is something that will be times with I. So if you do have something with I, that means that is an imaginary part. So for example, if z is equal to 2 plus with 3i, then the real part is this 2 because we couldn't see any I over here, and the imaginary part must be 3. If z is equal to 5 minus with 2i, then the real part is 5. The imaginary part will be -2. So do remember to take the sign as well. So yang ni jangan lupa lah, jangan tertinggal sign ni negatif, lagi down, dapat benda lain pula untuk imaginary. Okay, so now next. Equality of two complex number. So two complex numbers Z1 and Z2 are said to be equal if the real part on Z1 is equal to the real part on Z2. So this one normally we write them down as Z1 equal to Z2. So they will be equal if the real part on the left hand side is equal to the real part on the right hand side, and the imaginary part on the left hand side, which is for Z1, should be equal to the imaginary part for the right hand side, which is Z2. Okay, so for example, if let's say we are given m plus ni is equal to 3 plus 2i. So since we do have this equal sign over here, so that means the left hand side, if you take the real part on the left hand side, it should be equal to the real part on the right hand side. Imaginary part on the left equal to the imaginary part on the right hand side. Okay, so now let us compare them. Okay, so what do we see? This is the real part. So this is similar to here, real for Z1. On the right hand side, this is the real part. So that is why we can say that M must be equal to 3. Ni is equal to 2i. So N must be equal to 2. So that is what we mean by equality of two complex number. So as long as you do have the equal sign, you can easily compare the left hand side and right hand side of the equal sign. So tengok simbol equal, kita compare kiri dengan kanan. So yang ada I dengan yang ada I, yang tak ada I dengan yang tak ada I. Okay, so now example 4. Find A and B for the following equation. So A, we have A plus B plus A minus BI equal to 6 plus with 4i. Okay, so now let us compare the real part on the left hand side with the real part on the right hand side. So let us see. Okay, so this one is without an I, so this is definitely a real number. This is without an I as well, so both of them are actually a real number. This one, we times them with I, so that means this is definitely an imaginary number. So this is the real number, this is imaginary number. On the right hand side, this is without the I, so this is a real number. This is the imaginary number. Okay, so now we can obtain the first equation, which is when we compare the real part with real part. So A plus B is equal to 6. So that one will be the first equation. The second equation is A minus B equal to 4. So take the imaginary part on the left hand side and imaginary part on the right hand side. So you compare the left hand side, right hand side, you're going to get the first equation and the second equation. So since we have two unknowns and we have two equations, we can easily solve them simultaneously. So you can easily solve them because we got two equations and two unknown. Okay, so how to solve? There are two methods. You can use elimination method or you can use substitution method. So either one lah. Kalau tak ingat substitution tu, normally kita jadikan A sebagai subjek and then kita ganti. Elimination tu biasanya kita akan buang salah satu variable dulu untuk dapatkan yang lagi satu. Okay, so now this is elimination method. So first equation minus with the second equation. So you minus them. So A minus A, and then we can easily cancel out the A. And then B minus B. So what do we have is 2B. And then 6 minus with 4, so that one will become 2. So we're going to have 2B equal to 2. Or should I write this down for you? So we have A plus B minus A minus B, and this is equal to 6 minus 4. So that is how you do get B plus B. So 2B equal to 2. And then you should be able to see that B must be equal to 1. So substitute back into either the first equation or the second equation, and you should be able to see that A must be equal to 5. So A is equal to 5, B is actually equal to 1. Are you guys okay so far? Is this okay or is this hard for you? Okay. Okay, tak ada masalah. Okay. Macam XY. Okay, so kebanyakannya macam okay je. Okay, very good. Good job everyone. So let us proceed with the next one. So we have A plus 2B plus A minus B is equal to 9. So for this one, I'm going to give you around 3 minutes, I think will be enough. 3 minit lagi So I'll give you 3 minutes for you to do this question. And then let us check. Kalau siapa yang dah dapat answer nak tulis dekat situ pun boleh jugalah. Boleh kita tengok answer awak betul ke salah. So 3 minutes or should I give you 3 lah cukup. Okay, so starting from now. 3 minutes Apa? Kita tunggu lagi. Sampai ada lagi 30 saat lagi. Kok ada kawan-kawan awak yang nak bagi jawapan lagi ke? Nanti kita check betul tak jawapan tu. Tiga, dua, satu. Okey, mari kita tengok. Wah, ramai yang dapat jawapan lebih kurang je tu. Oh, 3. Okey. Asal badan nama? Sama je lah. Nama dia lawak betul. Tak apalah. Okay, so now let us see. Kenapa? Kenapa Akmal? Okay, tak apa Okay, so ramai yang dah bagi jawapan tu. So jom kita test lah, kita tengok. So siapa yang tak dapat jawapan lagi, tak apa. Kita tengok sama-sama, go slowly. Sebab dah lama cuti kan, so kadang-kadang masih ni lagi. Kenapa A dan B3? Tak tahu, nanti kita tengok. Okay, so sekarang. Oops. Kita ni. Okay, so now the first equation is A plus 2B equal to 9. So now you couldn't see anything with I, right? So we should plus with 0I over here. So when you compare with the imaginary part, you should be able to see that A minus B is actually equal to 0. So if we didn't see anything with I, it simply means that we have 0I. So itu je lah, tak ada I maksudnya 0I lah. Kalau tak ada number maksudnya 0 lah number tu. Okay, so the first equation, A plus 2B is equal to 9 and then A minus B is equal to 0. I think you can use elimination for this one. So 1 minus 2, so deduct them. 3B is equal to 9, B is equal to 3, substitute. And then A is equal to 3. So well done, good job everyone. You are doing great. So the answer is correct. A is equal to 3, B also equal to 3. Well done. Okay, so let me proceed with the next one. Algebraic operation on two complex numbers. Okay, so now we can do addition, we can do subtraction, we can do multiplication with complex numbers. Okay, so the same way as in polynomial, however, when you need to, you have to change, you have to make sure that the highest power of I should be 1. So that means if you do end up with I square, so this one normally will come out if you do multiplication. So if you do multiplication, you will end up with I square. So do make sure to use this one. You must make sure to use I square equal to -1 because the highest power for the complex number should be 1. The highest power for I of complex number should be 1. Okay, so given that Z is 4 plus 3I, W is 7 plus 5I, find what is Z plus W, Z times W. So firstly, let us add them first. So same thing with polynomial, numbers with numbers, unknown with unknown. Kalau polynomial kita panggil unknown lah, this time we panggil complex number. Imaginary number, sorry. Okay, so 4 plus 3I plus with 7 plus 5I. So 4 plus 7 first, so it will become 11. And then 3I plus with 5I, so it will become 8I. So 11 plus with 8I. Z times with W. So for this one, we should be very careful. Okay, so 4 plus 3I times with 7 plus 5I. So expand them one by one. So 4 times 7, 4 times 5I. 3I times 7, 3I times with 5I. Okay, so 4 times 7, 28, 4 times 5I, 20I, 3I times 7, 21I, 3I times with 5I. So the same way with polynomial, numbers with numbers first. So 3 times 5, 15, I times I is I square. So now, the highest power for the I over here is I square. So we should change this one using this. So I square is equal to -1. So change it to become -1. So what do you have is 28. 20 plus 21I is 41I. 15 times with -1. So it will become -15. So simplify them a little bit. This is real number. This is also real number. Simplify them. So it will become 13 plus with 41I. Lepas ni memang kena study. Ya, betul Raizo. Memang kena study. Maths tak boleh. Satu lagi. Okay, next. Conjugate of complex number. Okay, so what do we mean by conjugate of complex number? Okay, so A plus BI is the conjugate of A minus BI And A minus BI is the conjugate of A plus BI. So what do you see? This is the conjugate of this. This is the conjugate of this. So what really is the meaning of conjugate? Apa maksud conjugate tu sepatutnya? Okay, so conjugate is when you change the sign of the imaginary part. So this is because we want to do a reflection along the real axis. So that is why you simply need to change the sign only for the imaginary part. So for my tutorial, I think I already give you the Google site. So in that Google site, there's a part called tutorial week 1. So go to tutorial week 1 and then you're gonna find out one GeoGebra for this one. So saya bagi satu GeoGebra kat situ. So itu just untuk play around for you to see what do we mean when we say change the sign of the imaginary part. Sebab apa? Sebab dia ada reflection lah dekat situ. So boleh tengok dari situ lah. Itu maksud dia kenapa kita kena tukar satu saja. The imaginary part sahaja, bukan the real part. Like lah. Video tak gerak. Betul. Sekejap dah sejam kot, so dia bising. Lupa. Ya, saya tahu. Okay, so sekarang nampak saya dah gerak tapi jap. Kenapa skrin saya tak masuk? Masuk dah. Okay, dah gerak. Oh, tadi je. Nak kena repeat balik ke? Ada lagging sikit. Okay, so sekarang ni, should I repeat this part? I think better for me to repeat, I think. Okay, tak apalah. Right, so conjugate of complex number. So A plus BI is the conjugate of A minus BI. A minus BI is the conjugate of A plus BI. So now what's the difference between them is that we actually change the sign of the imaginary part. Okay, so here, this is our imaginary part. So instead of having a plus, we change it to become minus. This is a minus, we change it to become a plus. So this is what we mean by conjugate. Ataupun kalau kata bahasa official dia, it is actually a reflection for the real axis. So yang tu nanti kita tengok Nanti kita tengok dekat exercise dekat GeoGebra. Okay, so now next. Okay, so for example, 4 minus 3i is the conjugate of 4 plus 3i. Negative 2 plus 5i is the conjugate of negative 2 minus 5i. So do remember only for the imaginary number. See, this is imaginary, imaginary, imaginary. Don't change the sign for the real number as well. Okay, so conjugate of a complex number z is denoted by z with a bar, or you can actually use z with asterisk. So z bar or z asterisk. Video start lagi. Stress. Tak apalah. Biarlah muka saya je like. Bukannya awak tengok saya pun kan. Awak tengok apa yang saya tulis kan. Nak kena tengok juga ke? Ya. Boleh. Okey dah kot. Nampak dah tu rasanya. Okay, next salah. Dah pukul 5 lah, patutnya dah habis ni. Okay, tapi tak apa lah. Sambung lagi. Sikit lagi. Okay, so multiplication of conjugate of complex numbers give a real number. So that means if let's say you have a complex number a plus bi, you times with its conjugate, you should be able to get a real number. So for example, this one, if you expand them, then this one gonna be a little bit fast. So you do end up with a square plus b square. So you don't see anything with I anymore. So we firstly started with a plus bi, a minus bi, but now we have a square plus with b square. So no I. So this is a real number. Sekejap asal muka nampak macam lagging lagi. Tak apalah. Sekejap saya tengok banyak lagi ke ni? Rasa macam tak jauh dah. Satu je lagi kot. So satu lagi example lepas tu habis lah. Okay, so division by a complex number. So both the numerator and denominator are multiplied by the conjugate of denominator. So now our denominator is a real number. So we're gonna call this step as rationalizing the denominator. Okay, so for example, this one we have a complex number on top and at the bottom. So what we are going to do is that we are going to times them with the conjugate of our denominator. So look at your denominator carefully because we are going to times with the conjugate of the denominator. Okay, so for example, I think I'm gonna do only the first one. The second one, I leave that as your homework, okay? Okay, so A, we got 3 over 1 plus I. So 3 over 1 plus I, the conjugate of this, simply change the sign for plus will become minus. So 3 over 1 plus I times with 1 minus I over 1 minus I. And then of course you should expand your numerator and your denominator. So you will be able to get 3 minus 3I over 2. And then change it into Cartesian form. In Cartesian dia kena separate sikit I dengan number tu. So 3 over 2 minus 3 over 2 I. So that is how we simplify them if we have I in the denominator. Okay, so with that I conclude today's lecture. So I'll see you guys this Tuesday. Bye. Lupa nak tanya. Kan ada soalan nak tanya. Tak ada dah kot. Nak balik lah. Dah habis dah. Bye. Ada soalan beritahu.